we were talking about linear programming, and you want to graph a system of linear inequalities to find the solution of a system. So in this case, we want to sketch the feasible region. So over here, we have 5 constraints that we want to be able to graph and make sure that we have it represented in order to shade our feasible region properly. So we have a couple kind of easy ones to start with. The first one is 0 is less than or equal to x is less than or equal to 5. So if we go to our coordinate system and we make sure that we have this set up, so 1, 2, 3, 4, -5, 1, 2, 3, 4, -5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. And the first one said 0 is less than or equal to x is less than or equal to 5. So 0 is less than or equal to x is less than or equal to 5. And so basically all we have to do is we have to find where x is 0 and where x is 5. So where x is 0 is right on the y-axis. So that's the graph of x equals 0. And then we also have x equals 5. All right, so we have, right now that we have that graphed, we know that our solution has to be somewhere between the x-axis, between the y-axis and x equals 5, somewhere in between here. But there are some more constraints. So that was our first constraint. The next one we have is y has to be greater than or equal to 0. So y has to be greater than or equal to 0 is the x-axis. So we can graph this one here. Y equals 0. So we're to the right of this line, we're to the left of this line, and we're above this line, so that point is still good. Then we have 3 more constraints. We have x plus 7 is less than, x plus y is less than or equal to 7. And if we solve that equation, we can get, for our intercepts, if we make y equal to 0, this has to be 7. So if y is 0, then x has to be 7. And if x is 0, then y has to be 7. And then we can graph that line that goes in between there. So this is x plus y is less than or equal to 7. So less than or equal to 7, a good point to pick is 0, 0, just to check which way we should shade. So far, we are right of that, we are above that, and we are to the left of that. So if we take this equation here and we substitute in 0, 0, we can check to see if it works. So x is 0 is 0 plus 0 less than or equal to 7. So 0 is less than or equal to 7. That is true. So we want to shade to that side of the line. So that's right there. We checked to make sure which side to shade. And for this part here, we're supposed to shade in that direction. So we can see our feasible region is starting to show up a little bit, but we do have a couple more restraints to check. The next one, x plus 2y is greater than or equal to 4. And what we have to do there is get that in y equals mx plus b form. So I can write this right here. We'll say x plus 2y is greater than or equal to 4. And we can subtract x from both sides. And then 2y is greater than or equal to negative x plus 4 divided by 2. And then we get y is greater than or equal to negative 1/2 x plus 2. So then we can graph that line. So we start out at plus 2, which is right here, and then we go down 1 over 2. So down 1 over 2, down 1 over 2, down 1 over 2. And then we can graph the line that connects those. So this is the equation, x plus 2y, or the inequality, x plus 2y is greater than or equal to 4. And for that one, then we can check to make sure, and 0, 0 is not on the line again, so we'll check 0, 0. So 0, 0, substitute it in, and we get x is 0 plus 2 times 0 is greater than or equal to 4. We get 0 is greater than or equal to 4. Is that true? No. So this is not true, so we want to shade the other side. And then we have one last constraint, and we can see that we're starting to minimize even further. So this is checked. So this one is already y equals mx plus b form. So we can graph this one. So we go to positive 5, and then we have a slope of 1. So we have our y-intercept and the slope of 1. So we are graphing the line that goes through there. And then this inequality is y is less than or equal to x plus 5. So we can check to make sure what side we should shade. And so we can substitute the values in, and we get, if we check 0, 0, 0 is less than or equal to 0 plus 5. Is 0 less than or equal to 5? Yes. So we want to shade the 0, 0, the 0, 0 side. So here's our line. Here's 0, 0. That was true. So we want to shade this side. And so we have all the constraints. And then we want to shade this inside all of the arrows that we drew. And it has to be included in all of the constraints. So although this part here was included in one of the inequalities, this one is more limiting on the feasible region, so that ends up being our constraint for x equals 0 to x equals 4. This is our lowest constraint. Then we have one unit where the lowest constraint is y equals 0. And we can see that that's our feasible region there. So we ran through the process, and then we can just talk about the steps that we did. So the first thing is graph the constraints in y equals mx plus b. The next part is check to see which side of the line to graph on. The next thing, make markings. To show which side of the constraint So make markings to show which side of the constraint is part of the feasible region. And so those are those arrows that we used. You can see the red and the black and the blue. Those are the arrows to show which side of the constraint to shade. And then the last one is just shade the region.